Hello, everyone. My name is Camilo. Welcome back to the AI Explained for Business series. In this series, we try to go through some AI concepts in 5 minutes. Try to give it a simple business perspective explanation, and hopefully, you'll be better prepared for your AI conversations within your company. If you have a concept or question you want to go through, please leave it in the comments. I'll try to go through most of them. Don't forget to subscribe to the channel and ring the bell if you want to get notified when I upload new content. So now, let's get started with the question for this third video. The question was brought up by a colleague of mine. He worked in the traditional AI space, and he was asking me, what is the difference between the generative and the traditional AI approach to AI? So let's review. First, let's start with the traditional approach. Usually, in this approach, the companies needed to get their data from different enterprise data sources. It could be CRMs, it could be ERPs, it could be SCM tools, it could be different types of data stores. They were then consolidated by an integration scheme to a governed data store. It could be a lakehouse, it could be an enterprise data warehouse, but in any sense, this repository had all the governance processes to make sure that the data that was being used had the proper quality, control, and security enforcement so that business analysts could depend on. Now, on the AI piece, the data scientists extracted this data and they transformed it a little bit to make it usable for AI models. And this process is called data preparation. Data preparation is a loop, as you can see there. You begin massaging the information until you have a proper data pile that is worthy and ready for building a new model. One key thing here was that this back and forth in data preparation usually took up 80% of the effort within the whole process. So what we found is that 80% of the effort was spent on a low value activity because no value was generated from building these data piles. Actually, the value was generated next. So the data scientists took this data, they applied some algorithms that could be for different purposes, and with them, they extracted the insights that were necessary for businesses to attend better their customers and partners. This is where the 20% of the effort was spent and where the value was, the magic was generated. As you can see here, the process of training this model was very purpose fit. So your data was very dependent on the usage that you were intending. So recapping, you had a broad capabilities for training these models, so you could uh, cover and work with complex scenarios. Also, it usually required large amounts of data. As you can see there, it says millions of data sets, of data rows, and that usually required a large effort. Also, it was very difficult to repurpose a business model since the data was fit for one algorithm, so repurposing it was almost like starting brand new. The usage for these traditional AI models was either usually a classification model or a predictive model. We could use both, and those were the two most used. And from a business perspective, one of the key challenges that we had with traditional AI was that from 10 models that started from conception to production, 8 died in that process. And why did they die? They died for different reasons. One is the lead time. The time it took for the whole process to complete was too long. So, in that sense, business priorities changed. The data maybe was not enough to train a reasonably model that could explain reality. And there were a lot of challenges, especially in time to market. And why is that changing with generative AI? Generative AI starts off with a huge effort being brought forth by companies that are building what we call foundation models. These are models that are trained usually with unlabeled data based on large data piles, be it the internet or private piles of data. They basically did the hard work of training these models in a general purpose uh, objective. What do I mean by that? So you built a encoding type model. You could apply some data understanding around any concept. So you could do classification, you could do understanding, you could do tone analysis, all with one same model. And if you use a decoding type predictive model, you could do generative capabilities, you could do a lot of predictive capabilities on top of that model. But in general, it was built as trained once. And then the challenge was, how do you get your data? Which, as you can see clearly there, you no longer need millions of data rows. It could be thousands or even hundreds. And with even hundreds of well descripted examples, you could build through mechanisms as prompt engineering or tuning, model tuning. You could get the general purpose model to understand your data and understand the responses that you were requiring from your business model. So you no longer require large piles of enterprise data. You just need some very good representative scenarios and a good prompt to go with it. And with those two capabilities, you could basically generate different type of responses, be it a predictive, it be a classification, tone detection, translation, or other use cases. You can apply the same business model for different use cases. So here you start off with a foundation model. Most of the effort is taken off your hands. You would find pre-trained millions of data by these providers, whether it's Meta, it's IBM, it is Google, it is any other company. You would find these models pre-trained. Some of them are open and you can access them through marketplace players like, for example, Hugging Face. Some of them are open and you can use them for some applications. Some of them are open but restricted to commercial applications, and some are closed and require an acceptance of terms and conditions in order to use them. Also, the prompt engineer, which is this is something that is quite surprising. A prompt engineer with some good quality data that does not have to be millions of data points. It could be just hundreds of them. Could train a general purpose model to achieve equal or even better predictive capabilities than with the traditional AI approach. And that is surprising because then you could repurpose that model with some fast tuning to achieve different use cases. And what we have seen in the market is that the same teams that brought in the same time that they brought one traditional model to market, were being able to deploy 5 generative AI use cases. That is amazing. And from a business perspective, it is going to be a game changer because the time to market is is reduced so much that you can generate several different models and do iterative approaches and be more successful with AI like we've never had the opportunity before. And that is the reason why generative AI is a must for most enterprises. And we do know that everyone has it as a high priority. So don't forget to start your AI journey as soon as possible. So I hope you enjoyed this small video describing the difference between the two approaches. Again, if you have questions or comments, do leave them below and I'll go through them. And until the next time, thank you so much for your attention. and we'll see you tomorrow. Have a good one.